Hello, this is Mrs. Ward, and I'm going to go over the classwork for section 7.6, inverses of a square matrix. So numbers 1 through 6 just want you to show that B is an inverse of A. So in order to do that, the best way is, remember, if they are inverses and you take the product, so in other words, you take A times B, when you multiply those, you'd get 1, 0, 0, 1, or the otherwise known as the identity matrix. So I'm going to do this one by hand. So I'm going to find A times B. So remember, I'm taking row 1 times column 1. So this will be 1 times 2 plus negative 1 times 1. So 2 minus 1 will give me 1. Row 1, column 2 will be 1 times 1 plus a negative 1 times 1. So positive 1 minus 1 will be 0. Row 2, column 1 will be negative 1 times 2 plus 2 times 1, which will be 0. And finally, row 2, column 2 will be negative 1 times 1 plus 2 times 1. And when I do that, I get 1. So I do, in fact, get the identity matrix. Fun fact, if I were to do B times A, and I were to do 2, 1, 1, 1, times 1, negative 1, negative 1, 2, and multiplied this way. So when I multiplied row 1 times column 1, I would have 2 times 1 plus 1 times negative 1. I am going to get that same identity matrix because this is one of the few times where multiplication in matrices is commutative. In other words, it doesn't matter the order that I multiply them in. If they're truly inverses of each other, it doesn't matter if you take A times B or B times A, you will get that identity matrix back. Number 4 is asking you to do the same thing, except for number 4 has the added bonus of some fractions. How can we pass that up? So when I do row 1 times column 1, I am going to do 1 times 3/5 plus negative 1 times negative 2/5. So that'd be 3/5 plus 2/5, which would be 5/5, which is 1. Row 1, column 2, I'm going to do 1 times 1/5 plus negative 1 times 1/5. So that'd be positive 1/5 plus a negative 1/5, which will give me 0. Okay, hold on right there. Okay, continuing on, I'm going to do row 2, column 1. So row 2 would be 2 times 3/5 plus 3 times negative 2/5. So this is 6/5 plus a negative 6/5, which will be 0. And the last one, row 2, column 2, is going to be 2 times 1/5 plus 3 times 1/5. So that's 2/5 plus 3/5, which would be 5/5, which is 1. So I do get that identity of 1, 0, 0, 1. So I have shown that A and B are inverses of each other. Again, you could flip the order and do A times B and see that you're also going to get 1, 0, 0, 1. In exercise 1120, find the inverse. Since it doesn't tell me to use the determinant formula, I'm going to go ahead and do it using the identity matrix. So I'm going to do 2, 0, 0, 3, and then write the identity, which is 1, 0, 0, 1. And remember, the object of this game that we're playing is to make the left side look like the identity and the right side to look like my inverse. So so when I go to try and follow my pattern, I'm supposed to do 1 and 2 to eliminate the y, or to eliminate the x. Well, the x is already gone. So then what I'm going to do is I'm going to divide everything by 3 here. So when I do that, I'm going to have 2, 0, 1, 0, 0, 1, then 0, 1/3. And then for the step 2, I don't have to do anything to eliminate that y because it's already 0. So then I am going to divide everything in the top row by 2. So divide by 2, divide by 2. And I'm going to end up with 1, 0, 1/2, 0, 0, 1, 0, 1/3. So now I've made the left side look like the identity, and I've made the right side my inverse. So the answer to this question, the inverse, would just be the matrix of 1/2, 0, 0, 1/3. And that is the inverse of number 11. Number, the only way I can find the inverse of a 3 by 3 is to do that where I find the identity matrix. So I'm going to create a augmented matrix of sorts. So 1, 2, 2, and then put my 3 dots, and then I'm going to write the identity matrix over here. I'm just going to write it all at once. It's easier for me to do it that way. And then here's 3, 7, 9. And then -1, -4, -7. So again, I am trying to follow that pattern that I had on the 7-3 note sheet, where I'm doing row 1 and row 2 to eliminate my x, row 1 and row 3 to eliminate my x. I'm going to go through that whole pattern till the identity matrix shows up here, and then what's ever left on the other side of those dots is going to be my inverse. So I am going to do row 1 and row 2 to eliminate my x. So I decide that I'm going to multiply row 1 by a -3. That should work. -3 times row 1. And when I do that, remember I'm multiplying the entire row. So this is -3, -6, -6. There's those 3 dots. And then multiplying by -3, -3, 0, 0. It doesn't do you any good to forget to multiply the right side. You're not going to do yourself any favors. 7, 9. 0, 1, 0. And then when I add, I'm going to get 0, 1, 3, -3, 1, and 0. So that's going to be my new row 2. So row 1 is staying the way it is right now. So 1. And then row 2 is now 0, 1, 3. Then I'm going to do row 1 and row 1 and row 3 to eliminate my x. So it looks like on that one I'm just going to have to add. So here's row 1, which is 1, 2, 2, because they're already opposites, so I just need to add them. And when I add, I'm going to get 0, -2, -5, 1, 0, 1. And I'm going to write that down here, 0, -2, -5, 1, 0, 1. And I'm going to close off that bracket. All right, so I've eliminated, so the first column looks good. I had the 1 followed by the 2 zeros. It looks great. Then I am going to do row 1, sorry, lying to you, row 2 and row 3 to eliminate the y. So in order to do that, I am going to multiply row 2 by a positive 2. So we're going to do positive 2 times row 2. So when I do a positive 2 times row 2, I'm going to have 0, 2, 6, -6, 2, 0. And then I'm going to copy down row 3, which is 0, -2, -5, and then 1, 0, 1. And when I do this, I'm going to get 0, 0, 1. And then this will be -5, 2, and 1. So I have my last row done, and that -5, 2, 1 is the last row of my inverse. I'm just going to copy this stuff down. At this point, what I might want to do is I might want to pick up my calculator and find the inverse using my calculator to make sure that that -5, 2, 1 is correct. Because if it's not, I want to go back and check the 3 steps here that I've done and see if I made a mistake. It's easier to check 3 steps instead of checking 6 steps. So I would probably do that, but I've done that, so I know I'm right. So I'm going to move on. Now I want to do row 2 and row 3 to eliminate that z. So I'm going to multiply row 3 by a -3. So when I do that, I'm going to have -3 times row 3. So -3, that's going to be a positive 15. 6, negative 3. Copying down row 2. And I get 12, negative 5, negative 3. So, again, we said that row 3 was already done. And now row 2 is done. And now the last thing I have to do is I have to fix row 1. So the first thing I'm going to do is I am going to do 1 and 3 to eliminate the z. So when I do that, I'm going to multiply row 3 by negative 2. So negative 2 times row 3, which will be 0, 0, negative 2, 10, negative 4, negative 2. And then I'm going to write down row 1. And when I add, I'm going to get 1, 2, 0, 11, negative 4, negative 2. Now, so this now replaces this. And then I'm going to do row 2 and row 1 to eliminate that y. So I'm going to multiply row 2 by negative 2. So I'm just going to keep on going here because this is my row 1 right now. Yes, yes. And now I'm going to take 2, negative 2 times row 2. So I'm going to have 0, negative 2, 0. Then negative 24, positive 10, positive 6. And then this will be 1, 0, 0. And negative 13, positive 6, positive 4. So now when I finish writing this down, I'm going to 1, 0, 0. So when I do that, this side is the identity matrix separated by my dots, and then this side is going to be what my inverse is. So the final answer to my question is my inverse is just going to be this negative 13, 6, 4, 12, negative 5, negative 3, and negative 5, 2, and 1. So that is the inverse. That's how I do it longhand. Definitely check it on your calculator. And I would check it again as soon as I get here to this first, when the bottom row is going to be the first row you find. As soon as I get to that bottom row, that's usually when I put in my calculator and check it to make sure it's right. Because up until that point, you've only done 3 operations. And if you made a mistake, it's a lot easier to check those 3 than go back and check all of this work, because then it just becomes too intimidating. Okay, the next one, it says use the formula on page 545 to find the inverse. So remember, that's when I have this A, B, C, D, and I do AD minus BC, which is the determinant. And then to find the inverse, let's get these guys out of the way. To find the inverse, I take 1 over that, AD minus BC, and then I change this matrix a little bit. The D and the A switch places, and then the B and the C stay in the same place, but they change sign. So if they were positive, they become negative. If they were negative, they become positive. Okay, so let's do one. So 29, I'm a big fan of highlighters. Whoa, don't know what's going on here. So I am going to do, that's what I'm doing. So let's do it. So I'm going to take 5 times negative 2, which is negative 10, minus a negative 2. So that'll end up being plus a positive 2, which will end up being negative 8. Then to find the, so that's the determinant. Then to find the inverse, I'm going to take that 1 over that determinant, so 1 over negative 8. The 2 and the 5 are going to change places. So I'm going to put -2 here, put the 5 here. The 1 and the 2 are going to stay in the same place, but the 1 is now going to be negative. The 2 is now going to be positive because you're going to change the sides. Then I'm going to use this 1/8 as a scalar, and I'm going to multiply it by everything in there. So I'm going to end up with 1/4, 1/8, -1/4, and finally -5/8. And that's my inverse. And it's a lot easier to do inverses this way because there's a lot of fractions, and who wants to do all those fractions? All right, 31 is just chock full of fractions. So I am going to do that same thing where I do this minus this. So when I do that, I'm going to have 7/2 times 4/5, which I wrote 28/10. I bet your calculator is going to give you 14/5. So let's write 14/5. And then minus a negative, and then that's going to be a -3/20. So you're going to end up adding. And when I do this, I get 59/20. To find the inverse, I'm going to take 1/59/20, which is basically saying take the reciprocal. So I'm going to take that 59/20 and I'm going to flip it over and make it 20/59. Then I'm going to change the matrices where the A and the D, in other words, the 7/2 and the 4/5 switch places. So 4/5 will go up here, 7/2 will go down here. The 1/5 will become a -1/5. And then the -3/4 becomes a +3/4. Now, I'm probably going to do, honestly, just do it on your calculator. Taking 20/59 times 4/5, and I'm going to get 16/59, then 15/59, -4/59, and finally 70/59. And that's it. That's my inverse. And it's, again, a lot easier to do with the formula than having to do with all those fractions. Okay, the next one says use the inverse found in 13. Well, we didn't do 13. Whoopsie. So here's my matrix. See, 1, 2, -2, -3. That's problem 13. And let's find the inverse. And I'm going to just use the formula. So I'm going to take -3 minus a -4. So that ends up becoming 1. Well, 1/1 is just 1. The -3 and the 1 switch places. This 2 becomes positive. This 2 becomes negative. So now my inverse is just going to be -3, 2, -2, 1. So I take my inverse and I multiply it by my answers, which are 5, 10. And when I do that, I should get my x and my y. And how does this work? I wonder if, well, that's that ax is equal to b, where this is your coefficients, this is your answer. So to find x, you're going to take the inverse of a times b. And I can only multiply it that way because this is going to end up being a 2 by 2. B is 2 rows, 1 column. They have to match. If I tried to do it the other way and I tried to put the inverse after b, I'm not going to be able to multiply it. So I'm doing this, and I think I'm doing it old school. I am. So row 1, column 1 is -3 times 5 plus 2 times 10. So -15 plus 20, and I get 5. Then I'm going to do row 2, column 1, because there's only one column. And I'm going to do -2 times 5 plus 1 times 10. So 10 minus 10, and I get 0. So this is my x, this is my y, so my order pair is 5, 0. And then let's do a mental check. If I put in 5 for x, does it work? 5 minus 2 times 0, so 5 minus 0 is 5. 5 times 2 is 10. 10 minus 3 times 0, which is 0, so 10 is equal to 10. So it does work. So moving on to the next one. Use the inverse found in exercise 13 to solve the system. So let's go back. That inverse ended up being -3, 2, -2, 1. So -3, 2, -2, 1. We'll multiply it by my answers, 4, 2. And that's going to tell me what x and y are equal to. You could probably use your calculator. I don't know. that's negative 12 plus 4, so that's going to be negative 8. And then row 2 is going to be negative 2 times 4. So that's negative 8 plus 2, negative 6. So my order pair is negative 8, negative 6. Again, substitute into both and see if it works. Now, when it comes to ones like this, which is a 3 by 3, 17 you didn't have to do. We're not going to find the inverse by hand. Oh, dear heavens, no, we're not going to do that. So my coefficients, my coefficient matrix is this. And then I multiplied it by my x and my y and my z, and that's how I got my answers of 0, 5, and 2. So to solve this, to find out what x, y, and z are equal to, I'm going to take my inverse of my 3 by 3, which if it doesn't ask me to write the inverse, I'm not going to write it down. 6, 5, and I'm going to multiply the inverse of that, and I'm going to multiply it by 0, 5, and 2. So this is what this looks on the calculator, because this will be a calculator problem. You will have to find the inverse of a 3 by 3 by hand on your test and on your quiz, but once you do that, to solve these, you can use your calculator for the rest of them, and we'll be very specific in our directions. So here, let me get out my calculator. I'm on a calculating page. I'm going to hit that matrice button, go here to where I can select my size, and I want a 3 by 3. I want that square matrix so I can find the inverse. And I am going to type in those coefficients, which were 1, 1, 1, 3, 5, 4, and 3, 6, 5. Then I'm going to get outside this matrix. I'm going to raise it, so the power button, to the negative 1. That's finding the inverse. I'm going to hit the arrow key one time to sort of bring my cursor down. Then I'm going to hit times. I'm going to press that matrix button again. And now I want 3 by 1. I might be tempted to pick this guy, but this guy is not a matrix, so don't pick him. So go back here to the one that's customized. I do have 3 rows, but when I go down here, I only have 1 column, and that's exactly what I have, and that's good. So I'm going to do 0, 5, and 2 because those are my answers. Hit enter, and I get that, which makes me happy. 3, 8, and negative 11. And those are going to be my x, my y, and my z. So when I did that, so you can write it like that, or you can write it like this. Either way is acceptable, but those are my answers. So 45 says use the inverse to solve. So again, I take my coefficients, 3, 4, 5, 3. That's times my x and my y is equal to my negative 2 and 4. So to find x and y, I'm going to take the inverse of that. So I'm going to do 3, 4, 5, 3. Raise that to the negative first power, taking the inverse, and then multiplying by my answers, negative 2 and 4. Again, if it doesn't ask me for the inverse, I'm not going to take the time to actually write that down. I'm going to do this all on my calculator. So getting out my calculator, I am going to do the matrix here. You'll notice that this is a 2 by 2. I can use that because this is a 2 by 2. So I'm going to hit enter. And I am going to type in that matrix C, which is 3, 4, 5, 3. Make sure that you raise that. So getting out, make sure you raise that to the negative first power. Because if you don't raise it to the negative first power, you're not going to get the right answer. Times, I'm going to do another matrix C. I see this matrix C. That's the one I want, so I can hit enter. Or at all times, you can go back to that customized one. And I want negative 2. And 4, hit enter, and my answers are 2, negative 2. And that's it, I'm done. 2, negative 2, moving on to the next problem. I'm assuming you're going back and mentally checking. The next one, 55, use the inverse matrix to solve the system if possible. So again, let's see if I can just skip to x, y, and z. It's going to equal the coefficients 4, -1, 1, 2, 2, 3, 5, -2, 6. Take the inverse of that and multiply it by my answers, which are -5, 10, and 1. Again, all on the calculator. So I am going to go to that matrix. I'm going to the customizable one. I'm going to hit enter. I'm going with the 3 by 3. I'm typing in those coefficients. So 4, don't forget the negative sign. And then I'm going to get out of there and raise it to the -1. Bring the cursor down, then hit times. And now I want to do the matrix again. Have to go to the customizable one. I have 3 rows, but this time I only have 1 column. Hit OK. Those where my answers should go. -5, 10, and 1. Hit enter. And my answers are 1, 3. I'm sorry, -1, 3, and 2. And that's it. I can write my answers like that, or you can write them like this. Either way, you do have to show us this. You have to show us what you're typing into the calculator so we can see if you made a mistake. I hope this helps, and I will see you next time in class.